This is problem 34 from chapter 11, and it's about Poisson's ratio. Poisson's ratio is the fraction of lateral deformation over the fraction of axial deformation. So the symbol nu is the symbol for the Poisson's ratio, and it's actually a negative fraction of lateral deformation. This W is the width over the fraction of axial deformation, where L is the length. So we know that this member is getting longer, so we know it's under a tensile force. It's getting pulled apart. It's actually deforming by 0.7 millimeters, getting longer, and that's kind of contracting the width. So it starts at 75 millimeters wide and it contracts by 0.01 millimeters. That 0.01 is your lateral deformation. The fraction of lateral deformation is the how much it actually deforms over the original width. And let's think about sine. This width is getting narrower, so this is a negative value. So when we start plugging in numbers to this equation for Poisson's ratio, we have a negative of a negative, because this equation is defined as being a negative, but then we also have that negative 0.01 over the width. So that's the fraction of lateral deformation, and then we get to the bottom part. We have the actual axial deformation of 0.7, and we divide by the length to turn that into a fraction. And that gives us a positive value, which makes sense. So that's our answer. But I do want to point out the actual deformation over the length, or the actual deformation of width over the width. These are just, this is a way of saying strain lateral divided by strain axial. So we could also write Poisson's ratio as lateral stress, or negative lateral stress, over axial stress. I'm sorry, strain. Lateral strain over axial strain.
Made with Doodlecast Pro.